Hey everybody, it's Miss Moran and I'm here to talk about brand new kind of math that we're going to be working on from now to the end of the year, geometry. So we're going to be working with figures that are in 1 or 2 dimensions, so nothing three-dimensional, no solids, cubes, spheres, any of that. So talking about plane geometry, we have to give a bunch of background and vocabulary so that we're ready to talk about angles. So angles is what we're going to be starting with in geometry, but in order to do that you have to understand a few other things, which we're going to start with some of these vocabulary terms over here. So the first is a point, and a point just names a place on a plane. Our plane today is this piece of paper. A plane is going to be any flat surface. So this is a point and we name it with a letter. This is point Q. Okay. I also have 2 points here. These are points A and B. When points are connected in a straight path, we call that a line. And this straight path continues forever and ever in both directions. So we have these arrows on the end here. An abbreviated way to name that line is to call it line AB, which in math we don't like to write out a bunch of words. We like to use letters or symbols. So we can call that line AB, or it can be called line BA, kind of like students' names can have first name last or last name first. So that's line AB or line BA. A straight path through 2 points with no beginning and no end. All right, this is a version of a line called the line segment. It does have a beginning and an end. This would be line segment CD, or we could also call it line segment DC. Okay, it has a beginning and end and connects 2 points in a straight path. And then this is a ray. It's kind of a combination of both line and line segment. It has a beginning point at E, but continues forever in the opposite direction to F. We would call this ray EF, or as an abbreviation, EF, showing the arrow continues in the F direction. Now, what happens when those things meet and share an endpoint is we have an angle. So this is 2 different line segments. This is line segment LM. It's also line segment MN. But together, they share this point here at point M. That point that they share is called the vertex point. And that vertex point of a connection of this line segment and this line segment forms an angle. It's very important to understand when we talk about the angle, we're not talking about this point here. We are talking about the degree of opening from this line segment to this one over here. So we would call this angle LMN. We use this symbol in front of it, angle LMN, or we could call it angle NML. My middle letter is always going to be my vertex point, so it connects from L to M to N, or N to M to L. And then what we're going to spend the bulk of our next 2 weeks on is understanding all about angles, different types of angles, measuring angles, and decomposing angles. So we use this manipulative today. This is called angle legs. So what we want students to understand is this, a little hard to do one-handed, is basically a closed angle. So this is made up of these 2 line segments. I do have 2 segments here. And depending on the amount of opening, this creates different angles. So you could have a small opening, or it could open up even a little bit larger. Okay, it can go up. It can actually come all the way back around here until it forms a full circle. Not full circle, we didn't talk about today, but we will be talking about is 360 degrees. And so we're going to classify angles according to how much of an opening they have. And the more open they are, the larger the angle are. The more closed up, the smaller the number of degrees that they are. So we're going to start with several different types of angles that we're going to understand. Okay, the first being the right angle. Everything that we're going to use in this unit is going to be based on the right angle. So if it is smaller than the right angle, we're going to call that an acute angle. And that could be a small angle like this, or it could be opening up to here, or even a little bit larger. All of these count as acute angles. Okay, but it's not my opinion on what makes angle large or small. You might have a different opinion on what you think is something small. It's all going to be based on the right angle. And our definition of a right angle, even though many students have heard the term 90 degrees, that meaning doesn't really that number doesn't have a whole lot of meaning for them. 90 doesn't mean anything until they know what they're doing using a protractor, which will come later this week. but we are going to use a square, and we're going to use the definition of a square corner being what forms a right angle. So if I could put a square in that corner, I can form a right angle, okay? That can be rotated, okay? It can be like this, it can be upside down, it can be backwards, so it doesn't have to be any one particular direction. So in this case, we'll just leave it like that. That's going to form my right angle. So anything that measures smaller than that is going to be my acute angle, okay, up until the perfect right angle. If it goes beyond that, if the square corner doesn't fill that space, then that's going to be an obtuse angle, okay? Now, if this continues to open to a point, it becomes really large, we get to what's called a straight angle. So while this may look just like a straight line, it's actually not. This is an angle that has opened up to perfectly straight. We call that a straight angle. If it continues past that, we're going to call that a reflex angle. So now, not only is it going way past that right angle, it's gone past the straight angle and is now down here. And a reflex angle is going to be anything up until it gets back to that 360 degrees. So this is the vocabulary students will be expected to know. Again, the right angle, square fits in that space. They can use a corner of a Post-it or a piece of paper to measure that if they like, okay? The acute angle is going to be less than a right angle. If I put that in there, I can see that it is too small for that space. The obtuse angle is larger than the right angle, okay? It opens up more than that. My straight angle, actually going to be two of these side by side, okay? Kind of like a right angle back to back with an imaginary line up the middle. There's my straight angle. And then my reflex angle goes all the way around past that. And then here is the full circle. So we sort of use that square there to have my reader recognize that this is a right angle, because right angle is an exact, precise number of degrees, and sometimes you can't just tell by looking at it a difference of 1 or 2 degrees. We're going to use this little symbol here, that's sort of an arc, sometimes we call it a swoosh, to show how much of that angle is opening. So I can see from my base of my angle to that other line segment that that is a small opening. That's an acute angle. My obtuse angle, notice it starts to arc and swing larger. My straight angle is now swung half of what looks like a circle. My reflex angle is going to go even more than that. This could look like an obtuse angle, just upside down. That's why we want to use this little arc here to show that we're going around the outside. Okay, and then here, going all the way back around again, is my full circle. Okay, so that's the vocabulary we're going to look for. And then we're going to expect students to be able to recognize angles in a polygon. So a polygon being a closed figure made up of straight line segments. So what kind of angles do we have here? This is a rectangle, and this has 4 right angles. Okay, next I'm looking at a quadrilateral. This has, and they can use the square if they need. Okay, as I try to put that in there, I see this is an acute angle, so that opens up small. This is an acute, and this is an acute, and this one over here swings open larger, and so does that. My square is not going to fit in that corner, okay, this corner down here. So we're going to call these obtuse angles. So this would have 2 acute and 2 obtuse angles. All right, this triangle that I have here, okay, those are all acute angles. It's 3 acute angles. Okay, this hexagon I have here, okay, I try to put this, I'll look at this corner down here. As I try to put this in there, you see that that is a much larger opening. Sometimes it helps students to use a different color. They can trace over that. And if they can see it separated instead of a big mix of all the line segments there, sometimes that helps. Okay, so from here to here, that opens up larger than a right angle. This is going to be an obtuse angle. And all of these are obtuse. 1, 2, 3, 4, 5, 6 of them. 6 obtuse angles. All right, and then I have a trapezoid. This is made up of 2 right angles. And this one is large. That's an obtuse angle. 1 obtuse angle and 1 acute angle. Okay? All right, that brings me to just triangles specifically. Okay, so triangles will be named based on the types of angles they have and the number of those angles that they have. Sorry, a little out of focus there. So in these triangles, these are going to be called acute triangles. Now, this is a little bit tricky for students to understand because every triangle will have acute angles. An acute triangle is one that has all acute angles. All three of those are acute angles. All three of these are acute angles. So an acute triangle is going to have all acute angles. Okay, sometimes we say cute angles, those tiny little angles, like cute little things like babies and puppy dogs. Small little things are cute, like cute angles, acute triangle. All right, and a right triangle, if it has any right angle at all, it's going to be called a right triangle. So one right angle and the other two are going to be acute. Again, every triangle is going to have acute angles, at least two of them. But if it has any right angle at all, then that's going to be called a right triangle. And those are two examples of those. The length of the sides don't matter. It's all about that one angle right there. All right, and then an obtuse triangle is going to be anything that has an obtuse angle. Again, it also has two acute angles. But if it has any obtuse angle at all, it's going to be an obtuse triangle. So that angle right there is obtuse. That's going to make that an obtuse triangle. Okay, so after we can classify and decide what type of angle we're looking at based on this vocabulary, then we're going to get into actually measuring angles and looking at number of degrees. Before we actually start using a protractor for that, though, we are going to use some math, some algebra, some number sense, and some decomposition to determine the number of degrees in certain benchmark angles. We're going to start with a full circle. We want students to understand that that full circle, as they open from here all the way around to here, is going to be made up of 360 degrees. Okay, so 360 degrees, the number of degrees when I'm measuring on a protractor, each one of those smallest units that we have is going to be a number of degrees. Okay, I have one full circle. So if I have a full circle, we're talking about taking that angle, again, and opening it up all the way around, swinging that second line segment around 100% all the way around is going to give us 360 degrees. So let me say, well, what if we took part of that circle? This is where our fractions from our last chapter come in. Okay, so if I had half of my circle, I need a third hand. This is going to be kind of rough here. Okay, if I have half of my circle, so half of my circle, I can think about that as multiplication or division or addition. So what plus what is going to equal to 360 degrees? 2 times some number is going to equal to 360 degrees. I'm taking 360 degrees and I'm dividing it by 2 parts. How many degrees am I coming up with? So we're using algebra here to determine that. So if the full circle was 360 and I've now split it into 2 parts, then this part of the circle, half of that, is going to be 180 degrees. 180 plus 180 equals 360. 2 times 180 is 360. And 360 divided by 2 is 180 degrees. All right, so then if I want to look at 1/4 of a circle. Okay, so I want to take 1/4 of my circle here. Okay, now what angle are we looking at? Well, we're breaking up my circle into 4 parts. Okay, and how many degrees are formed in this corner right here? Well, hopefully students recognize this from what we already talked about, that that square fits into that corner. And if I know that that square fits into that corner, I have 4 of them here. This is where that 90 degrees comes from. 4 times some number equals 360 degrees, or 360 degrees divided by 4 parts is going to be what number? Well, if I know my basic facts, 4 times 9 is going to be 36. So each one of these is going to be 90 degrees. So I've got 90 degrees in all 4 of those. And 90 times 4 is going to give me 360 degrees. So when I see 1/4 of a circle, 1/4 of a circle is going to be equal to 90 degrees. All right, next we're going to get into 1/8 of a circle. Well, if 1/4 of a circle is going to equal 90 degrees, then 1/8 of a circle is going to become half of each one of those. Okay, getting back to our fractions. You thought we left fractions in the dust, but here we are again. All right, so here's my 1/8. I can see that this is a small angle. I can see that that's an acute angle. Okay, it's less than my 1/4. Now, how am I going to figure this out? So 8 times some number is equal to 360 degrees. That may not be the easiest problem to understand, but I also know we already just did 1/4. Okay, so if this is 90 degrees, then each one of these is going to be the two parts that add up to 90. Each one of these is going to be 45 degrees. 45 degrees makes an acute angle. So we got 45 degrees. I can check that by doing 8 times 45, and that will equal to 360. So all of those added up together, 8 times 45 degrees to give me 360. And this is an acute angle, and we did talk about acute angles being less than right, and also we're also going to learn later this week less than 90 degrees. 2 more to show you. Thanks for hanging in there. I know it's kind of a long scale today. All right, if we took 1/3 of the circle. Okay, so we're really just decomposing. This is a term that we used a lot when we were working with fractions, breaking up fractions into parts. So we're going to decompose the circle into 3 parts that equal to 360 degrees. So what number times 3 equals to 360 degrees? Knowing my facts, 3 times 12 equals 360 degrees. This is going to be 120 degrees. This is going to be 120 degrees, and so is that. All 3 of those together equaling 360 degrees. Okay, so here's my obtuse angle. It measures greater than a right angle, and also we're going to learn greater than 90 degrees. If I try to put that in there, you see it doesn't quite fill that space. It's larger than 90 degrees. All right, and then from that, you can also do the 6 of the circle. That would be taking that 3rd circle piece, and we're going to split each one of those in half. So, a couple ways to look at this. Sorry. So, I can either say 6 times some number is going to equal to 360 degrees. You can also treat that as division, 360 divided by 6. Okay, or we can take what we did before. If we knew that 1/3 of the circle was 120 degrees, basically we have split each one of those in half to make 6. So each one of these is going to be 6 times 6 is 36, so each of these becomes 60 degrees. Okay, and 60 times 6 gives me 360. Okay, these also form acute angles. They're less than right angles. That square is not going to fit in that corner. They're less than 90 degrees. All right, I thank you for hanging in there for a long introduction to angles. Stay tuned later this week or early next week for an instruction on using a protractor to measure angles precisely. All right, thank you so much.